I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
The race to the moon is no longer about flags, prestige, or scientific curiosity. Today, it's about something far more valuable: water. Hidden inside permanently shadowed craters and mixed within lunar soil, this frozen resource, often called moonwater, is rapidly becoming the most strategic asset in space exploration. Why? Because water is more than a life support ingredient. It can be turned into breathable oxygen, potable water, and, most importantly, rocket fuel. When you split water into hydrogen and oxygen using electrolysis, you create the most efficient chemical propellant known for deep space missions. That means lunar water isn't just a resource, it's the key to building refueling depots in space. Instead of hauling fuel out of Earth's deep gravity well, spacecraft could refuel on the moon and launch deeper into the solar system at a fraction of the cost. In many ways, moon water is the oil of the 21st century space economy. Scientists estimate that the moon may contain hundreds of millions of tons of water ice. The richest deposits appear in polar craters, where sunlight never reaches, areas colder than Pluto. Modern instruments like NASA's LRO and India's Chandrayaan-1 and 2 missions have mapped hydrogen signatures that strongly suggest massive reserves of ice grains mixed within lunar regolith. Future systems may use thermal mining, microwave extraction, or heated probes to release the trapped ice. The engineering challenge is enormous: frigid darkness, abrasive dust, and the need for autonomous machines that can run for years. But the potential payoff is transformative. The United States is moving aggressively with NASA's Artemis program, which explicitly focuses on establishing a sustainable lunar presence. Part of that strategy is deploying robotic ISRU, In-Situ Resource Utilization systems, to test, extract, and process moonwater. Companies like Intuitive Machines, Astrobotic, and Blue Origin are designing landers and robotic miners, while SpaceX envisions a future where starships refuel in lunar orbit before heading to Mars. The goal is simple: build a cislunar economy where fuel, oxygen, and manufacturing materials come straight from the moon. China is also racing toward lunar resource control. Its Chang'e missions have successfully returned samples, mapped polar volatiles, and scouted landing zones for the upcoming International Lunar Research Station, a joint project with Russia. Chinese scientists describe water ice as the strategic lifeline of future lunar operations. Their plans emphasize large robotic excavators, solar-powered processing plants, and eventual human-tended research sites near the moon's south pole. Russia, despite limited budgets, continues to pursue lunar resource capability and maintains partnerships with China. Roscosmos has outlined concepts for automated lunar refineries and has repeatedly stated that moonwater is essential for long-term human presence beyond Earth orbit. Their scientific community views water ice as both a geopolitical asset and a gateway to deep space propulsion. Other nations are entering the competition too. India, having delivered some of the most detailed moon water maps, is preparing follow-up missions focusing on polar landings. Japan, through JAXA's Slim Lander and partnerships with Toyota and private companies, is testing the precision landing and mobility technologies essential for future mining. Even Europe, Canada, Australia, and South Korea are investing in lunar ISRU technology, robotic prospectors, and international regulatory frameworks. Beyond national programs, the private sector sees the moon as the next trillion-dollar frontier. Startups are prototyping autonomous excavators, AI-based navigation for permanently shadowed regions, and cryogenic storage tanks to hold super cold hydrogen without boil-off. The long-term vision is the lunar industrial belt, refueling stations, manufacturing depots, solar power farms, and communication relays forming a logistical backbone for everything from lunar tourism to asteroid mining. Extracting moonwater is the first step toward that future, but it comes with new questions. Who owns lunar resources? How do we prevent conflict over high-value polar territories? What happens if one nation attempts to monopolize the best ice-rich craters? The current legal framework, the Outer Space Treaty, prohibits sovereignty claims, yet it leaves huge gray areas around commercial extraction. As more nations land on the moon, and as corporate players expand their presence, establishing clear international norms will be vital. Despite the geopolitical competition, the vision remains hopeful. Moonwater could enable humanity to push beyond Earth orbit sustainably, fueling exploration, powering habitats, and creating the first off-world economy. It could become the stepping stone that transforms the moon from a symbolic destination into a thriving hub of activity, science, and industry. The real lunar gold rush has begun, but instead of gold, it's powered by ice. And the nations that learn to extract, refine, and use moonwater will shape the future of space for generations. The journey toward this new era is just beginning, and humanity is closer than ever to turning the moon into our gateway to the solar system. Thanks for watching. Subscribe, follow, or visit IDSTH.com for more cutting-edge defense and tech insights. See you in the next one.